Alrighty, everyone, I have 6 o'clock, so we're going to go ahead and get started. If there's any concerns or questions, there is a chat option. Go ahead and shoot me a chat if there's anything that you guys need. I'm happy to answer anything that I can. So welcome to the inaugural Marine Storm Spotter training. We've never done a marine version of it, so we are going to want a lot of feedback from you guys. Just let us know if there's anything that we should add or subtract from this. My name is Liz Somerville. I'm one of the lead forecasters at the Corpus Christi office, and I am also the Marine Program Leader. Let's see if we can get this to actually go. There we go. So today we're going to talk about a few things. First, we're going to talk about the National Weather Service and some of our marine hazards products. And then we'll talk about marine weather phenomena, some of interest, then weather instruments, concepts, and severe storms. A lot of this will be a lot like what we see on land in this section, but it all pretty much applies over the water as well. So I felt it was prudent to keep it in. Then we'll have a little break, and then we'll talk about some storm spotting techniques, some beach safety, because while it is a marine talk, the beach is right there, and so we do kind of keep that in mind when we talk about marine safety. And then we'll talk about how to do some reporting. So first thing, we're going to talk about the National Weather Service and some of our marine hazards. Each year we have billion-dollar weather disasters, and this graphic just shows 2020 billion-dollar weather and climate disasters that happened just in this one year. What this doesn't show is a lot of the marine problems. So every year we get millions of dollars of lost cargo offshore. We have ships that go down, we lose lives in vessels, all in just the marine zones. So that is something that we don't always qualify when we talk about disasters. So we're going to kind of push on that stuff just a little bit more in this presentation, and how to be safer in that kind of situation. With the Weather Service, we do have 122 forecast offices, 13 river forecast centers, and we have 9 national centers, and those are like the Ocean Prediction Center, the Weather Prediction Center, Hurricane Center. Some of these you've heard of quite a bit. We are obviously down in South Texas there. So here in Corpus, we're responsible for 15 counties, all the way from Mexico to the coast. And we do the bays and the waterways. We do our nearshore waters, and you can kind of see how they're divided there. And then we do offshore waters as well. And what we do is we keep a continuous watch, 7 days a week, 365. It doesn't matter if it's Christmas, if it's a holiday, what's going on. We are going to be there for you. Our mission is to protect life and property. In fact, this image here is from, I believe it was Hurricane Hannah, when we were doing a briefing in the morning when shift changes. So, we're always in the office regardless of what's happening. So if we're always there and we have all this equipment and we have all these things, why do we need spotters? Spotters are able to give us real-time reports. You guys can see the ground. We can't necessarily see what's happening all the way in the radar, or out over the waters, or farther away from our radar. So we need people who are trained, who are safe to go identify any of those severe storms or anything that's happening out there, to help us be able to do better with our warnings, in order to see if we need to continue a warning, if we should go ahead and let it go, because sometimes what we see on radar may not be reaching the ground, which is part of our big thing. It's the radar problem. It's our primary tool when we issue warnings, but the earth is curved and the radar beam travels in a straight line. So as you get further away from the radar, you can see how in this picture we go up and up and up. So what we see farther away from the radar is quite a bit higher than ground truth. So we really do need people out there who can tell us what's happening at the ground. We also have satellite. We use a lot of satellite for our tools, but there are limitations to it. What if, like in this case, we have upper level clouds? I can't see what's happening underneath those. If it's nighttime, sometimes we can't see all of the little details, although we do have excellent channels for that as well. But there are other limitations. Too much rain, cloud covers, smoke, there are all kinds of limitations that we have with satellite that don't necessarily let us see what's happening. And we're seeing the top layer on satellite. We're still not seeing what's happening on the ground. But what are some of our marine threats here? We have wind and waves, obviously. Severe weather and water spouts, sea fog, lightning, and then we have coastal flooding, rip currents, and then hurricanes and storm surge. I'm not really going to touch much on hurricanes and storm surge, simply because if we do, that could take a whole other presentation. In fact, we do have other presentations, and those will be coming out shortly, I assume, with hurricane season approaching. So I'm going to kind of gloss over and kind of skip the hurricanes and storm surge simply because we have whole other presentations for that, and it would take hours and hours longer. So for severe weather, we have special marine warnings. We can issue these, they're kind of like the severe thunderstorm warning over the wire. Our criteria is winds that are 34 knots or greater, hail of 3/4 inch in diameter, if there's a tornado or water spout. So if there's a tornado on shore and we expect it will go offshore and become a water spout, then we go ahead and issue the special marine warnings. These generally last less than 2 hours. These are not for long-term things. But when we see these issues, we expect folks will hopefully listen and take safe harbor. We have marine watches. And of course, a watch just means prepared. Be prepared if there's a watch issued. Conditions are favorable for the weather event to occur. We do gale watches, storm watches, hurricane force wind watches, and then hazardous seas watch, which we actually don't do at our office, but some other offices do. So I wanted to include that so you could see this is something that happens out there. So in this case, it just means that, so if we have a gale watch, it's going to be from 34 knots to 47 knots. A storm watch is from 48 knots to 63 knots. And then hurricane force, which is not the same thing as a hurricane, is 64 knots. The wind speeds are the same. So the criteria is the same. It's just a different mechanism of reaching that criteria. So when we say hurricane, if it's a hurricane watch, it's a little different than a hurricane force wind watch, though the results will feel similar. The next thing we have are warnings. So gale warning, storm warning, hurricane force wind warning, and again, for other offices, they do have a hazardous seas warning. Again, the same criteria, it just means it's happening. We know it's going to happen very soon or it's already occurring. So we're hoping folks will seek shelter immediately. We also have advisories. When we have an advisory, we mean that there's a hazardous condition that is expected or occurring. They generally don't reach a warning criteria, but we do go ahead and put out some information for folks to know that there are some hazardous conditions happening. For instance, today we have a small craft advisory. So wind speeds were a little bit low, but they were not, they weren't gale force yet, but they were still reaching 20 to 25 knots at a minimum. So we'll see a lot of those as well. We tend to see more advisories than the watches and warnings simply because the criteria for the watches and warnings are a little bit higher. Now we also work with the Storm Prediction Center to talk about severe thunderstorm risks. Now a lot of folks might think this is over land, but it actually does go over our waters as well. So occasionally you will see a severe thunderstorm watch that reaches over our waters. If we have no thunderstorm or just light green and no thunderstorms, there's no severe storms expected. So then we have marginal, slight, enhanced, moderate, and high. Obviously, as you get into the more hot colors, it generally means that we have more of a situation, there's greater chance for some widespread severe storms. So how we work with them. So what happens is we work with the Storm Prediction Center. They issue a severe weather outlook, generally days 1 through 8, but then the details really start to form on days 1 through 3. And about an hour or two before we think the storms are going to develop, we'll start looking at severe thunderstorm and tornado watches. Hopefully it won't be, something that we have to deal with too much, but these are things that happen. And then of course we can get, warnings that hopefully are 10 to 15 minutes before you feel the impacts, though warnings can happen very, very quickly, especially over the waters when storms can just kind of pop up on us. So that's when we would have a special marine warning. So again, I'm going to hit on watch and warning again because people get confused on these. Watch means be prepared. A warning means it's happening. So just be aware that if you see a severe thunderstorm watch, we need to be prepared for some severe weather. And in this graphic, you can actually see that it does go over the waters, which is very helpful. As far as a severe thunderstorm warning, or in our case, a special marine warning, it means that the weather is occurring now. So we really need to pay attention and take shelter. So now we're going to move into marine weather phenomena of interest. If anybody has any questions, or you can't hear me, or I'm going too fast, go ahead and shoot me a chat, and I'm glad to clarify anything that I can. So we all know about tornadoes. They're a violently rotating column of air in contact with the surface. They have to be connected from a cloud to the ground. They have to touch the ground. They are not always visible as a funnel cloud, though. So you can have a clear air tornado, so you don't see the funnel cloud, but you would see debris. So basically, why that matters to us is that we have water spouts, which is basically a tornado over the water. They do tend to be a little weaker as a general rule, but they are there and they can be very dangerous for mariners. So the two basic types are supercell and non-supercell. So a supercell tornado or water spout, a lot of this came from the Florida Keys here, so bear with us on the pictures and things like that, but these supercells are larger and faster and stronger tornadoes. They are infrequent over the waters in general. The energy is usually derived from like a jet stream or large scale weather system. You might see it in a tropical storm or hurricane rain bands. You might even see it in a squall line, but generally you don't really see the supercell ones. What we get mostly around here are non-supercell, smaller, slower, and weaker water spouts. And the energy is derived from buoyancy arising from vertical heat, moisture contrast. You'll see it on a cloud line. You'll see it, again, on squall lines too as well. And there are different stages of water spouts. So they did a study in 1969, I believe, in the Florida Keys that did the life cycles of a water spout. The first stage was the dark spot. Prominent light colored disc on the surface. You really can't see it unless you're in the air. There might be a small funnel cloud there, but generally it's just the dark spot on the water. Then you see the spiral pattern. So what you'll see is primary growth. This is the primary growth stage. So this is when we start to see light and dark kind of circles around the dark spot in the center. Again, it's still best viewed from the air, but there is a chance you might be able to start to see some things happening on the surface. Generally, though, you're going to see this mostly from the air. Now we'll start to see the spray ring, and that's the concentrated ring around the lengthening funnel from the funnel cloud above. So you'll start to see the actual visible funnel and circulation and spray on the water. So this is when we see that it's actually a funnel cloud on the water surface. And in order for wind speeds to actually throw sea spray, they figured it out for tropical storms. It was 43 knots, which is not even storm force yet, but it is still pretty significant for any mariner to be out there in 43 knot winds. So then we have the mature water spout. It's characterized by a spray vortex. It's got maximum intensity in this case, and then it'll start to weaken eventually, but we have this funnel cloud that we actually see. We know it's there, it's on the water, and so we really see what's happening with this water spout. Then finally, we have the decay stage. It'll start to weaken. We'll see that the funnel will start to thin out usually. It'll start to just kind of go away and you won't see it anymore. It'll just dissipate. So here we have a radar loop of a 2018 squall line. Overland, it had large hail, 60-mile-per-hour winds, and we did see a peak wind of 81 miles per hour offshore. And when you look at that, you don't really see a whole lot in the way of tornadoes or water spouts. However, they did happen on this day. It's just very hard to see. So in this one, we have a sea drift. At sea drift, we see there was an EF1. Very difficult to find these water spouts on these radar images. So we know that a boat was capsized, several homes were damaged. So while this took place some over land, there were some that went overseas. So you can see that it's very difficult to find those. Again, Holiday Beach, difficult to find again. It was another place where, along the beach where we had some issues with another water spout, hard to find again. And you can kind of see, where the arrows are, where the rotation actually is. And again, we had another one here. It's a little actually easier to see on the reflectivity, which is ones on the left. The velocities are on the right. And you can see that there is a bit of a rotation there. Again, the arrows kind of note that for us, so it makes it a little easier for us to see, but those are very hard to find. So with our water spouts, you can see how tricky they are. They don't really show up very well on radar. In this case, you don't really see it very well at all. You can kind of see there the little rotation there, kind of south of Rockport. And if you look over on the reflectivity, kind of in the same-ish location, you can kind of see there's a little appendage hanging off of that little squall line, and that's where you can see it. Again, here's another one from Port Lavaca. We have the picture of it. We have the radar imagery, and then we have the reflectivity, and we have the velocities. It's almost impossible to see right there that there is a water spout, but clearly it was happening. And again, the same thing, offshore of Port Aransas, it's hard to see it at all, but there it is. We can clearly see it in the images, in the photograph, but it was very difficult to see on radar. Usually when we see a rotation that broad, we don't really look at that and say, oh, okay, clearly there's a tornado there. So water spouts are really tough for us to catch. So it's really important for us to have spotters who can go out and when they see it, let us know. We're not looking for people to go out and chase them. That's not what, we're not looking for people to put themselves in harm's way. But if you see a water spout, it's really important for us to know so that we can be issuing the proper warnings. Another one is another marine hazard is sea fog. Doesn't seem like fog would be that big of a deal. However, sea fog is one of our most significant challenges to marine operations, particularly in the northern Gulf of Mexico. Places like Corpus and the Houston Ship Channel and Galveston often experience visibility restrictions from the sea fog, generally in the winter and the spring. It seems like it should be fairly simple to form, right? Warmer, moist air moves over cold water. The warm air cools to the dew point temperature, and it causes the air to become saturated, and then fog forms over the northern Gulf. So it seems like it would be super easy to forecast. However, it's deceptively difficult because we don't know. It requires a lot more ingredients, I guess, than just the warmer water, cooler temperatures, and the warm air moving in. You can see in this graphic, we do have the warm air kind of coming in from the southeast, east, and almost southeast are the best directions for us, because what happens is the water is going to move, or the air is going to move over the warmer or the cooler waters fast over a long period of time. So that's a big difference for us. So the extent of the cooler near shore waters and the wind direction will affect the density and duration of the sea fog. So in the wake of cold fronts, we get high pressure that builds in east, kind of over the southeastern US, and then the winds turn to onshore. When that happens, we get warm, moist southern Gulf air, dew points in the 60s or 70s, moving north across these cool continental shelf waters. The amount of time the air spends over the cooler waters has a significant impact on how dense the sea fog will become. So an east to east-southeast wind that nearly parallels the Gulf Coast will be the best trajectory for heavy sea fog. And by that we mean less than or equal to a half of a nautical mile. As the winds continue to turn more southerly ahead of the next approaching front, warm, moist air crosses cooler waters more quickly, and so it has less time to cool to saturation. So we tend to get less fog or thinning fog. That doesn't make it go away though. We can still have winds 10 to 15 knots and it will still remain in place because sea fog doesn't generally go away until there's a frontal passage or an air mass is changed. It's very different than like inland radiation fog, where if you're windy, it tends to kind of mix out and you don't get the fog. With sea fog, it's a little trickier because the winds will pick up and you're still going to be foggy. What you're seeing in these two graphics, and the one with the orange, is that we have IFR probabilities for visibility, and you can kind of see, so that just means it's going to be very foggy. You can kind of see how over the waters it's doing that. And then on the right graphic, we're seeing visibilities again with satellite overlaid, and you can see as the winds move toward, you can start to see the fog sort of forming there. Okay, and now we're going to move into weather instruments, concepts, and severe storms. This is where we're going to get kind of in the meat and potatoes of storms. It's very much like the overland SKYWARN. So one of the things we're going to talk about is what we use to view our weather. We have the Doppler weather radar. It operates 155 radars are nationwide. They go 24/7, 365. We've actually recently done some great updates to kind of help our radars last even longer. But they don't detect the weather at the ground. They only do it in the atmosphere. So while we can do scans every 1 to 2 minutes, we can kind of see what's happening. We're not able to see what's on the ground. Further complicating things is that the radar doesn't reach all that far out into the waters. So we're not always seeing everything over the waters. We're very fortunate that our radar is very close to the coast, but that's not the case in every place. As you can see on the map, there's a lot of them, but that doesn't mean it reaches across everyone's waters. So there are some limitations, and that's partly why we need the ground truths. So basically our radar operates like this. It's kind of cool. So initially it went through and just kind of sends out this vertical pulse and a horizontal pulse, and it goes back and forth between the two. And when we get back, we go and we see that it sends out a pulse, it bounces off of something, and we receive a pulse back. And that's how we can tell, okay, it's scattered back to us. That's where there's something in the atmosphere. There's a whole lot of equations and algorithms that transmit it and tell us what this picture now becomes. This is obviously a simplified animation of it. So with one of the things we see when we get our radar imagery is reflectivity. So just because it's red doesn't mean there's hail. It just means that there's intense rain or storms that are shown by more warmer colors. You see the light colors like blues and greens. Those cooler colors indicate lighter rainfall. And then you go into the yellows, reds, and oranges, and those are going to be your heavier rainfall. And if you see white or pink, that does usually indicate hail. As far as velocity, we also get that from our radar. The warmer colors are moving away from the radar, cooler colors are moving towards the radar. If they're next to each other, as you can see in this image, there's a spin. So in this case, we look at this and we think, oh, maybe there's a tornado there. So we would confirm that. We would look at that. In this case, there was a tornado warning issued, but we needed a ground truth to tell us if that's true. Is there a tornado there? So another tool we have is the satellite imagery. GOES 16 is one of the coolest satellites we've had in a long time. So we can get 1 minute imagery that's available to us. We are able to ingest that stuff into weather models for more accurate forecasts. This is a geosynchronous orbit, so we constantly get this. It's located about 22,000 miles up, and we are able to actually drill down into these storms with incredible detail. So that is one of our features, but again, we still have those limits that we discussed earlier about how you can't necessarily see what's happening under there. One thing I'm going to point out though is if you watch this loop, you can kind of see up towards the, well, really along the bands there, you can see these like bubbles almost in the clouds. Those are overshooting tops, which we'll go into in a bit, but they're indicators of strong storms. So, and the next thing we have are weather balloon observations. We have sounding that comes from aircraft, but we also have these observations that we take twice a day sometimes 4 times a day if the weather requires it. This I'm going to show you guys a video of it from, I believe this was Hurricane Hannah. All right. So during that, it was actually during the hurricane, and they do go out and we do go launch balloons in the middle of a hurricane. Seems crazy, but we need the information in order to see what's happening aloft, what's happening in the whole column of air if we're able. We want to be able to put that into models and make sure that all the information that we're getting is the most recent and best available. We also get surface observations from ASOS sites, AWAS, all sorts of automatic observing stations. You might see those, you know, the observations coming in from KCRP or KALI or something like that. But those observations we often get from automated observers. We also have our buoy network, which we do occasionally get, you know, we get some buoys out there for our exact waters. We have a new one out there of, I believe it's 42092, just off of Port Aransas. So that's been pretty exciting for us because now we can get water temperatures, we can get winds, waves. So that's much more useful. So we have a lot of buoy observations as well as surface observations. And I know you're here in the marine talks, so you're wondering, why on earth do I care about these surface observations that are over land? Well, the weather's coming from somewhere and it's going somewhere else. So it's always useful to know what's going to be happening if the way, as generally weather does, moves from the west toward the east. So it's a good idea to see what's happening inland as well as what's happening over the waters. So now we're going to talk about some thunderstorm ingredients. This again is important over water just as it is over land. First, we have, you know, a cyclone that develops. When we say cyclone, we don't mean hurricane necessarily. We don't mean anything. It just has to do with the direction of rotation of a large scale system in this case. So it's basically turning counterclockwise. So we get a wave that kind of develops, and then it kind of gets stronger, and we can kind of see the fronts sort of moving through. You'll see some colder air and some warmer air, and that's basically what causes the wave. Is the cold air kind of moves one way, and the warm air starts to lift a little north, and the cold air kind of pushes in, and you'll see it kind of push together, and the cold air generally moves faster than the warm air. So it becomes a mature low pressure system, and you can see the little purple front there is an included front. That's where the cold air has caught up with the warm air already. So and once the warm air or the cold air overtakes the warm front there, we have the system that dissipates. Some of our main ingredients for a thunderstorm are instability, moisture, and lift. Those are really the three things we need. We need the instability so that we can lift the parcel up, an air parcel up. So if something pushes air up, is it going to keep going? If there's more instability, if the air parcel is going to keep going up, that's a greater potential for severe thunderstorms. We need a lot of moisture. No point, you can't get thunderstorms if there's no moisture. So our main sources of moisture are the Gulf of Mexico, obviously, especially since we're talking about the Gulf of Mexico generally. But we also get moisture from the Pacific Ocean. We get winds that transport the low-level moisture inland, and we'll start to get some convection. Those showers and thunderstorms will eventually move offshore for the most part. It's generally how they work, except with sea breeze, which is a little bit different. But we do often see that they will kind of move toward the waters. And then we have lift. So this is what's going to make that air parcel lift up. So what's going to push it up? What's going to make it matter that there's instability? We have large scale boundaries like fronts and dry lines. We're all pretty used to the cold front and hearing about dry line convection and things like that. But we also have sea breeze and outflows. So we will often see an outflow boundary that pushes over off the shore, and we'll see some thunderstorms form over it. It makes sense, especially once it gets past the cooler shelf waters. It gets over those warmer waters, and we'll start to see storms kind of lift off of those because now it's got warm, moist, unstable air with a lifting mechanism. And that's for, just for general thunderstorm life cycle here. So now we know how they're going to form, but what are they going to do? We get a towering cumulus stage. So we'll get a little bit of rain maybe, and the storm's kind of building up. We can kind of see there's, rising air. And then we'll get storms, or the intensity of the rain will kind of increase, and we'll see that there's a lot of lightning, and we'll see storms that we'll see this large sort of updraft, and then kind of toward the backside of it, we'll see the winds coming down. We'll see a downdraft, and that's where we're going to get our rain most of the time. Then we have a dissipating stage, which is when the intensity kind of goes away. We do have the potential for downbursts in this stage. So basically it's just going to drop the water and the wind down. But generally in just a general thunder, we don't see quite as much severe as we do in these severe thunderstorms. So if you're wanting to look for updrafts, birds. They are great. So if you're out over the waters and you see a bird flying and all of a sudden it just kind of rises up with the air, look for those. Those are a great indicator of updrafts. So we can kind of see, like, where is the thunderstorm going to form? Are there going to be thunderstorms here? Are they near clouds already that are sort of looking like thunderstorms? Is there an updraft there? Birds are amazing for that. Okay, so when we have severe thunderstorms, we have all of those ingredients: the instability, the moisture, the lift. Wind shear is needed. Wind shear is just a difference in winds from down below, lower in the atmosphere, like toward the ground, up higher. It can be a speed difference. It can be a rotational difference. So it can be, we have north winds here and then east winds aloft. And it can it can be both. So what happens is that we get an increased shear for severe thunderstorms. So we have all these lifted storms, just like normal. And this shear kind of causes it to rotate. It tilts the storm in the updraft over. And it allows for it to exist for a longer period of time because the downdraft falls away from the updraft. So it's not choking itself out. So common types of severe storms that we see are squall lines. We see a lot of squall lines. That tends to be where we see a lot of severe weather coming across the waters. We can get moderate to strong winds. It has this sort of linear appearance on there. And we will often see a shelf cloud. In the picture on the top, we see the shelf cloud there. We know it's a shelf cloud because it's pointing away from the rain. The point of the cloud is. So we see the shelf clouds. They're long-lived. They can be severe, and they can produce strong straight line winds. They can produce hail. They can be widespread damaging winds. And then sometimes we get tornadoes out of them. It's not as common, but we do see them. In this case, we can kind of see where there's going to be a tornado. That's possible. We see a bowing segment in the line, which indicates these straight line winds. But then we also see over in the top left photo, there's a little kind of appendage sticking out. That's where we're more likely to see a tornado form. They're usually pretty brief, and they're not as strong as, say, a supercell tornado, but they do happen. And so that's one of the things that we're going to look for when we see things moving toward the coast. We're going to want to see, are we seeing these bowing segments, and are we going to see these little appendages? What you do often see is as they move offshore, those bowing segments can really push out and become a little stronger. Oddly enough, it's just because of friction. There's less friction. So they'll push a little further out. So that's one of the things that we also look for. These, in particular, are these bowing segments. In that, we also have what's called a bow echo. It's kind of how just the winds sort of push further out as they, when the strong winds kind of reach the surface. We have heard of derechos. We do get them on rare occasions, but they do happen across here. They do tend to happen more up north. Those are a type of bow echo. It's just that they have to have, I believe it's 100 miles wide swath of like 400 long mile wide difference of damage. in this case, a bow echo is just a smaller version of that. So you'll start to see winds kind of pushing the storms forward. And that's when you'll see those bow echoes. If you look at the radar imagery, we have the reflectivity on the left, and you can see where the rain generally is. And you can actually see on the leading edge toward the south where there's an outflow boundary. It's kind of pushing ahead of it. And then up on the left or on the right side, you can see just in the center there of where that storm is, some really bright colors, some almost teal. That's where the strongest winds are, and that's where we're going to see severe winds generally. We also have supercells, which I think a lot of us are familiar with. They have moderate to strong windshield. They live a long time. They can, hours generally. I mean, they can last a very long time. We call it a mesocyclone. So you'll see that sometimes. It does not mean there's a tornado right then. It just means that there's a strong storm scale rotation through the depth of the storm. Usually those are isolated, but we can see them embedded in lines, and we can see them embedded in hurricanes. So in the bands of a hurricane, they produce larger hail, damaging winds, and mostly if you see a violent tornado, it was produced by a supercell. We can see them out of violent tornadoes out of other types of thunderstorms, but generally that's where they're going to come from. We can identify them by a hook on the radar. Doesn't necessarily mean there's a tornado again. It just means that there is some rotation. We do know that the rotation goes all the way up the columns, so that is something that we're going to be looking for. As far as the structure, you can see that we have a big anvil cloud at the top. And what that is where it's hitting a stable layer up above. Often it's the tropopause, so it's a layer of the atmosphere. So we get these cumulonimbus clouds, they form up, they hit the top where there's a stable layer. And sometimes that updraft is so strong it shoots through that stable layer. And that takes a pretty strong storm. So if you see that, it's something we're really looking for and being very concerned about. And we saw that on satellite. So that was one of the interesting things that we can see very well on satellite and not necessarily on radar. And then we have a wall cloud. You can see how tiny a tornado would be compared to the actual supercell. They're very small. We have a wall cloud, and then a tornado would come down from the wall cloud. The rain tends to stay on one side, although we do get rain-wrapped tornadoes. So we'll get rain and hail near the downdraft, and we'll get the overshooting tops and things near the updraft. So one way we see that is we start to see how the structure of an actual supercell is. So what we see is like a classic supercell containing a violent tornado. This was the May 3rd, 1999 in Moore, Oklahoma. This one is not quite to Moore yet, but it gets there. We see the forward flank, which is the larger portion of the storm. Then we see the rear flank, which is where we're going to see the tiny little start of the hook. The tornado would be in the tiny little hook there. We'll see a rear gust front, so you'll start to see some winds pushing out from there. We'll see a hook echo. The hook is just where the mesocyclone is. The tornado comes near the hook. We will see light rain, small hail as we get closer to the hook, larger hail as we get even closer, and we can see an anvil edge for miles. Those can be blown for miles away from a supercell. They can have wall clouds and shelf clouds. So supercells are very powerful. So they do live a long time often, and often they can be quite severe. Again, we're looking at another kind of diagram of what we're seeing of a supercell. We've kind of labeled it the action area. That's where you're going to see a tornado and hail and things that are very the more severe weather. You'll see a rear flank downdraft. That's going to be strong winds. You'll see an updraft that you can't see on the radar. And then you have the forward flank downdraft. So sometimes, I don't know if you guys have felt it, but if there's a severe thunderstorm or a supercell nearby, you can feel the wind shift quickly. And that's one of the downdrafts that you're feeling from that storm. So if you are looking at a supercell, if you're on the coast or you're driving to go somewhere and you see this supercell and you know that there is a tornado or there's something there, you want to move generally south. You don't want to go in front of the storm. It's not safe to be up in the path of those tornadoes. Yes, we see storm chasers do that on TV. No, they are not smart to do that. It's just dangerous. So generally, we ask folks to, if you do see it, escape to the south, because for the most part, these storms are going to move more northeast or easterly. So you don't want to be in the path of those storms. So we'll talk now about some cloud features with the severe thunderstorms. So when we start to see storms form, we'll see turkey towers. Now they're just vertically developing clouds. It shows that, you know, we've got some more instability. It's starting to, the cap is weakening. We're not going to get the suppression of storm development. So it just means that there's a chance we're going to get some thunderstorms. When we get a strong updraft, we can see that because we can see, like in this case, it pushes up and we can see it flattening out as it gets up there toward the top layer there, toward the unstable, or toward the stable layer. And then the clouds will grow, spread out horizontally, and we'll see that these storms are getting a lot stronger. If you see these overshooting tops, like we talked about before, the updraft is so strong, it's able to lift through the top of that storm. That means generally that the storm is very strong or severe. When you see a tilted or rotating updraft. So there's wind shear within the storm, and that's going to be our mesocyclone again. And it is strongest in the mid-level. So you don't generally see it as much on the ground as you do in the slightly higher up in the middle levels. So in this satellite image, you can kind of see how it's actually it's rotating. You can see this updraft that's there. So it's kind of another tool we were able to use to see that. Another thing we see are wall clouds. That's when we see a lowering beneath the base, and that's going to be a rain-free area generally because that's beneath the updraft. Rotation and lowering is persistent in a wall cloud. It's directly beneath the mesocyclone, and that's generally where you're going to see your tornadoes form. They form beneath the wall cloud. Funnel clouds. We see those actually kind of a lot. They're usually, in this case, for supercells, they're found beneath the wall cloud. It's not in contact with the ground, but there is a sign that there's an increasing tornado potential within a storm if it's a supercell. Now, we will see funnel clouds over the waters that have to do more with temperature differentials and the light winds. And so we'll see like tropical funnels. They do not indicate stronger storms. It just has to do with temperature differentials. So we do see those. If you see them, we're extremely interested. We want to know about it so that we can tell people, hey, we're seeing these things, and we can keep a closer eye just to make sure that everything is going the way we think it's supposed to be going. We also see mesocyclones and supercells again. Sometimes it looks like what the mothership pictures, I've heard them refer to that. And that is, again, a cool, these are just great graphic pictures of supercells where you can actually see that they're kind of rotating and just the power of the storm itself. And in a supercell, you will see often a hail shaft. So you'll have this rain-free base where the updraft is. Then as a storm, you can even see how it's tilted. You can see this tilted storm, and then you have rain, and then small hail and large hail. And of course, we're seeing the large hail closer to the updraft because it simply can't keep that hail in there up high enough, long enough. So as you get to the larger hail, you're getting closer to the updraft in this case, in most cases. And we'll also see some flanking lines. We get organized zones of like cumulus clouds that connect to and kind of go outward from the thunderstorms. One of the things we see that are really cool are mimosas clouds. They kind of look like pouches, and they can accompany severe thunderstorms, but they don't produce any severe weather. And we have seen them without severe thunderstorms. It's really just sinking air that kind of results in these sort of pouchy looking clouds. Another thing we get are downbursts. So we'll get microbursts, macrobursts. And what that is basically, when we say microburst versus macroburst, it has to do with the distance. So we might see 2.5 miles, 2 to 5 minutes, and those are straight line winds. And a lot of people want to say, oh my gosh, it was a tornado. But actually, if it's a microburst, it can produce winds that are as strong as, if not stronger than tornadoes. So we can see 168-mile-per-hour winds. That's incredibly fast and is enough to do a lot of damage. We can also see macrobursts, which are larger than 2.5 miles, and they last a lot longer, 5 to 20 minutes. The winds generally go up to about 135 miles per hour, which is, again, still incredibly strong and enough to do a lot of damage. In the image, you can kind of see what it looks like in the initial stage of a downburst. You start to see this cloud sort of descend from the sky. Basically, what's happening is that cold air is just dropping to the ground, and it pushes out, and you get this great just burst of air and rain. And so what you'll see is this rain-cooled moist air that accelerates downward, and you can kind of see once it hits the ground, how it gets this little curve up because it's pushing. It has nowhere else to go, so it goes out. At this point, that is when the winds are the strongest at the surface, and they're the most danger to mariners, to aviators. This is a dangerous situation to be in because those winds have nowhere else to go, and they are going to come towards you, and it is going to be very strong, and they are hard to forecast when exactly that's going to happen. Another cloud we might see are shelf clouds. We get the leading edge of a gust front, basically, and we know it's a shelf cloud when it points away from the rain. So if it's moving toward clear air and you see the cloud like this, you're going to say that's a shelf cloud. So which one's the shelf cloud and which one's the wall cloud? Well, we just talked about it. So we know that the rain is underneath the shelf cloud. So it points away from the rain shaft. So that's the downdraft. It's got straight line winds and it points away from the rain shaft. The wall cloud kind of points toward the rain shaft because that's where our updraft is, and that's where the tornado region would be. So when we see outflows like this and we see this like shelf cloud here, we see that air pushes away from the storm, and that air is going to be colder. So you're going to really feel the difference in that gust front, and often we do feel that, how cold it is. That is when we're going to see some stronger winds. So when we look out over the water and we see something like that, you should brace yourself for stronger winds and try to get support if possible, because these winds are going to be, they have the potential to be very strong to severe. All right, so let's take a little break. We'll take 2 minutes or so, and then we'll come back and we'll chat on some more about the weather. All right, I think we're going to get ready to get started again. If anyone has any questions or comments or anything, please let me know. Chat, questions, there's 2 links there on there that should make it so that you can just type your questions in. Or I think you can unmute yourselves and just ask if you have any questions. I'm happy to answer them. We're going to go ahead and get started again and try to get through the rest of this. Hopefully you guys are still with me. All right, so we're going to go over some storm spotting techniques. So spotting can be dangerous, obviously. So one of the things that we need to be careful of is that tornadoes can be obscured. We can't see it. There can be rain wrapping, there can be clouds. It could just be difficult to see. So that is a big problem that we have, and so that's why we want you to be very careful if you are out and about. We're not looking to put anybody in any danger. Another thing that we have a problem with is that it's really hard to tell the difference between certain clouds. And it seems like, oh, tornado, easy, but not necessarily. Generally, tornado has a smoother appearance. The problem with that is sometimes you have debris that obscures it, you have rain that obscures it, so it's harder to see. But we see it touching the ground and it's rotating. We'll see a funnel cloud sometimes, though. It's not touching the ground. But again, we've talked about this before. Tornadoes don't necessarily have a visible funnel. So now what? You have a funnel cloud. It doesn't look like it's touching the ground. What are you going to see? Well, in our case, we're going to see spray. So if we see spray, we know that there's a water spout or a tornado over water. The same as if we're on shore and we see one coming that way, we'll see the debris. The last thing is we'll see scud. Some of us like to call that the scary looking clouds. They are kind of ragged. They can look like they're moving and rotating, but they're not. They're just rising. And what that often is it's just kind of clouds that are broken away. So it looks scary. It looks like a tornado. It can really be alarming. But generally they don't have any. They're not severe weather clouds. They can be accompany severe weather, but they aren't actually going to create any severe weather themselves. So another thing we want to look for is we want to find the updraft and the downdraft. So that's going to help us find the most favorable spot for severe weather. Again, if we have the updraft, that's where if we're in a supercell, we might see a tornado, a wall cloud. So we're going to look for the lowering bases in the updraft. In the downdraft, we're going to see more outflow. We're going to see squall line, or we're going to see, pushing straight line winds and more hail. So we really want to stay back from the storms and be able to see where those locations are. You want to know when you're spotting what's going on around you. If you have a radar app, have someone with you that is watching the radar. Don't drive and use the radar. You want to know what direction storms are moving, so you want to keep a safe distance, and you want to have an escape plan. Don't get stuck on a back road somewhere where you don't know where you are and it's just the one road, because things change and they change fast, and it can be very alarming, especially if you don't know where that storm is going or coming from. One thing we always like to say is if the tornado looks like it's not moving, it might be moving towards you, so you should leave, move parallel. Again, we want to keep a safe distance from storms. You can see this. This is actually, some of these are taken by one of our meteorologists in our office, Matt, who has done a lot of storm chasing. And you can see he keeps a pretty good distance away from these storms because he knows it's safest. You don't need to be up in a tornado to see the power of a tornado. They're enough. If you've seen one, you know. If you've seen a water spout, you know. Those, they are strong, and they even the weakest ones are strong, and they are enough to toss your boat around. They are enough to cause significant damage at a port. They are dangerous, so stay back from them. We never recommend going spotting at night. If this lightning flash hadn't happened here, you wouldn't see that tornado. So if you are out boating at night and you know that there's storms, and they could be, tornadic, or there's thunderstorm watches or tornado watches out, or the best bet is to not go out at night when you see those things, just because you don't know what's there. You can't see it. So the next thing we're going to touch on is beach safety. So we go from severe weather and all this good stuff that I think most people are very interested in, and we move into beach safety, which doesn't seem like it applies to mariners, but in fact it does, because a lot of folks are out on the beach. When we're out getting ready to do boating, we're on the beach. When we're doing things, that we're on the beach. So these are important things for all of us in the marine world. So some of the beach hazards that we have are rip currents, coastal flooding, high surf, and lightning. Not going to touch too much on coastal flooding. I think that's pretty self-explanatory. It's when water floods the coast. So we're not going to do too much of that. But one of the things that we see when we go to the beach is we see these flag conditions. So it's important that we familiarize ourselves with the flag conditions. They're not always out, but they do try to make sure that they're out. And it's the best if you can look for those flags to see, hey, how's it going today? For instance, in this case, conditions were strong winds, there was a strong current, there was heavy surf. Red flag is dangerous. When you have a blue flag, I believe that's like marine life. So even with a green flag, we still have some marine hazards because inherently the beach is dangerous. It's strong, the water is strong. So we have to be cautious when we're at the beach. One of the main hazards we see are rip currents. They're just powerful currents of water that move away from the shore. Now, one thing about these is that we can even see longshore currents with rip currents. So you might get kind of knocked off your feet at sometimes if you are caught in one of these currents. But you just relax. You're going to be okay. You escape parallel to it. So what we say is wave, yell, swim parallel. So wave to get help, try to float, tread water, and then you want to swim parallel to the shore to get out of the current. So watch how the water's taking you and swim across it. Don't try to fight it, because you can't outdo water. Water is just too powerful. The currents are too powerful. They can sweep the strongest swimmers away. So you do want to swim near a lifeguard. Rip currents are basically just the fast flowing channels of water. They can reach speeds faster than an Olympic swimmer can swim. They are easiest to spot from elevated positions. So that's kind of frustrating because you're on the beach. You don't really want to have to go like fly a drone up to look at it or something. But you know, we can look around and see that there's dark or muddy or choppier waters, choppy waters in the surrounding areas. So we're going to see, where are the waves not breaking? That looks like the best place to swim, but it's not. It's actually where the rip currents are going to be the most likely. So how do you survive a rip current? They don't pull you over, so just relax. They're not going to pull you under the water. So if you try to swim against it, you're just using up your energy. You don't want to try to swim directly to the shore, because you're just going to wear yourself out. You swim along the shoreline until you escape the current. When you're free from it, you swim at an angle away from there to the shore. If you can't reach the shore, relax, face the shore, and call and wave for help. If you're too tired, relax, tread water, float, and ask for help. If you're possible, you want to swim at beaches with lifeguards. If you can't swim at a beach with a lifeguard, never swim alone. Always take someone with you and have a cell phone so that someone can call 911 for help. But if you're in doubt, don't go out. Don't go swimming if you're concerned about a rip current, or if you are unsure if you're a strong enough swimmer. There's no need to put yourself in danger just to go hopefully have some fun. You're welcome to, just wade, have fun in the water, but you don't have to swim that far out if you're that concerned. One of the biggest things for mariners and beachgoers alike is lightning. A lot of our beach activities are impacted by thunderstorms. Actually, the leading cause of lightning fatalities are fishermen, because they're, on these piers and rocks and sandy beaches and bows, and they have their giant rods. And so it's sort of it's sort of a dangerous situation when there's any kind of lightning. Sunbathing, playing ball, those kinds of things are the second highest cause of lightning fatalities, and then camping. So We have to be really cautious when we're out on the water or when we're out at the beach. Pay attention for lightning, pay attention for thunderstorms. Those can be hidden from your sound because of the water and the waves themselves, and because people are having fun, or the motor of the boat. There's all sorts of different ways that those sounds can be hidden and we don't see them. And since they generally move from more west to east, it's often behind us. So we don't see them until they're on top of us, especially if we're heading out away from the shore. So we want to keep a watchful eye in all directions. We want to head to a safe place as soon as any sign of approaching storm is there. You want to monitor your forecast and radar as much as you can. And you need to have a sturdy place to go to, like a vehicle or a fully enclosed building, not a picnic shelter or open-sided structure. If you're camping, try to have a hardtop metal vehicle nearby, so you can get into your car or your truck or whatever. As soon as you see a thunderstorm, you can get into that rather than being out in the open. It's a lot less safe to be out in the open. Another thing we have are high surf. The waves are constantly changing, so you want to listen to the rhythm of the waves. You want to watch for changes in the waves. You're going to stay back further than you think if you're on shore, and you need to know your local forecast. Now that applies to folks on the boats too. You need to listen to the rhythm of the waves. You need to watch for changes, because waves can sneak up on you. We have sneaker waves that come in and they're a lot higher. We can have wave heights that are suddenly higher than they expected. Again, when we talk about wave heights, we're only talking about the average of the top third highest waves. So we're not talking about waves that could be higher necessarily. We're saying this is the average top third. So waves could be a foot or two higher even than what we're forecasting, because that's what we're forecasting, the significant wave height, not all wave heights. So that's something we need to be careful of, especially in small boats or on the beach. One of the ways that you can look at that is to find our surf zone forecast, which is what I have kind of in the picture here. I've put what our surf zone forecast looks like. So we'll see it has tide information, wind information, weather, UV index, thunderstorm potential, surf height, wave periods, and the current risks. It has the today, tonight, and tomorrow, and then it also has an extended forecast on there as well. It's very useful if you're headed out to the beach or if you're going boating. Go ahead and look at these things. Even though you think as a boater it may not matter that much, it does. It gives you some good information on there as well. Although we also have our coastal waters forecast, and those are good as well to show you about what we're thinking for wave heights and winds in certain areas of the waters. Again, like the bays and waterways are separated usually from our near shores from our offshores. So we have those distances and differences. So how do we report? That's the big one. So for us, we're delighted to get any report. So if you give us a brief call, if you go on social media, we have Twitter, we have Facebook, and you tag us, we will look and see what we've got. You can please be specific. What did you see? When did you see it? Where did you see it? If you're out over the waters and you want to say, I saw it 30 miles off of Port Aransas, we'll find you. That's okay. We can look and see where it looked like there was severe weather. If you want to give us the latitude and longitude, land or oversea, that's great too. We can do that. We're very happy to take any reports that you have. Of course, we love pictures. It's always nice to see the actual ground truth of what's happening, as well as just getting the reports, but never put yourself in danger to come give us a report. It is not worth it. We're okay. One of the best ways to get a hold of us is to give us a call. You can call our SKYWARN line for toll-free numbers. And then we also have a direct line at 361-289-0959. Those are good numbers to call us. The direct line calls directly into our operations. If you call that line, you will get a forecaster who can tell you what's happening. And we promise that we will appreciate any reports you give us. Another way is social media. We have Twitter and Facebook. Our little tag there is at NWS Corpus. We monitor it 24/7. We have reports. We like pictures. You can direct message us. You can ask us questions. We will do our best to answer any questions that we get. If you see any hail, we want that reported. You can measure or estimate the largest hail, coins, golf balls, softballs, baseballs, preferably not marbles because marbles are all different sizes. So just to estimate it, over the waters, again, 3/4 inch hail is where we're looking for. That's when we start to say it needs a special marine warning. Winds, we can measure or estimate the speed. Obviously, we don't get a whole lot of damage to trees or structures over the waters, but you can estimate the speeds and let us know if there was any damage to any boats or any ports or anything that you've seen. Water spouts or tornadoes, also let us know. Wall clouds, funnel clouds, those are really important for us to know too. One of the things that we have on here is flooding. So if you do see coastal flooding, it's actually a really good thing for us to get reports on, in particular, because we don't have a good way to see that. We don't necessarily get any reports of that from the Department of Transportation. We don't see closed roads. So feel free to contact us if you see any coastal flooding. And by that, we mean water reaching up to the dunes or very close to the dunes. Let us know. If there's any vehicles that are stranded, we're there for that too. We would like to know about that too. We also have MPing. It's a project that we did. It's a free app. You can just go on there, you download it. It doesn't cost anything. Everything's anonymous. Reports are sent directly to the NWS here. It's very user friendly. It's super easy to do. So all you have to do is go to mping.nssl.noaa.gov and you can just download the app. Yeah, I think you can do it on the App Store and just submit reports that way, and it'll give you just drop down menus. What are you seeing? And you put it in there. It's very easy and really one of my favorite features that we have there. So sometimes we might contact you. If you put yourself in our spotter network, we will contact you by using a database that we have. So it will have all of our spotters in it, and it has sheriffs and emergency managers and spotters and employees and everyone else that wants to report. And we put it in there, and that way we can say, okay, we know that a storm happened here. We can actually draw a little box and say, hey, there was a storm here. Can you tell us about it? We can send emails or we can call in this case. Sometimes we do both. But, this is one of the major ways that we're going to start doing storm verifications. So if you see something over the waters, or if you're out and about and we know that you are near the coast or whatever, we may email you or call you sometimes if you choose to put your number in the storm spotter database. One of the ways that you can get to warnings from us, and this is really important too, I want you to have the warnings. We do have multiple ways that we push out our warnings. We issue the warnings and then they get pushed out for NOAA weather radio, local TV and radio, outdoor sirens. Remember, those sirens are for outdoor only. They're not meant to warn you inside. If you're lucky if you hear it inside. We get the wireless emergency alerts on your phone for like tornadoes, flash floods, extreme wind, hurricanes, tsunamis, storm surge, winter weather, severe thunderstorms. You'll get a lot of those. You can kind of modify it to how you need it. You can get them on internet sites. And if you get these warnings, let people know around you, especially if you're on the beach or you're over the water, you're on the water and you see somebody boating past you, hey, there's a storm coming or something. Those are good things that we can do to help others kind of be safe. So we're trying to build a weather-ready nation. In this case, we want you to have a plan in place for you and your family. We want your friends to be safe. We want you to be safe, your neighbors, your coworkers. Have emergency kits on your boats, life jackets, as well as some other things that are in there that could be safe to help you. You probably want to have not just cell phones, but radios that we can reach out and talk to people if there's an emergency. Know your Coast Guard's numbers. Know how to get in touch with people to help you be safe if you need a rescue. Have a weather radio in your boat, your office, your home. Review your insurance policies. Not all will cover wind and wave damage. So you need to be careful and make sure that all of those things are covered. And also at your homes, make sure that all those things are covered. So you're going to want to review all those. Have an emergency kit in your boat, have it in your house, have one in your car. It just is a good idea to go ahead and be prepared. Don't be scared, be prepared. So you want to plan. If you are with a business, you can become a weather ready ambassador. The businesses and organizations are becoming ambassadors to promote weather safety. They coordinate with the Weather Service on potential collaboration opportunities. Employees kind of get educated on workplace preparation. So if we know something's going to say hit the aquarium, they know how to get people to safety. And then they can share some success stories of preparedness and how they prepared for an event that kept them from being in danger. So before the storm, you want to have a plan, you want to know your plan, and you want to practice your plan. So in our case, generally, if we know there's going to be severe thunderstorms, we're going to want to be probably in port. Probably not going to want to be going out and boating. Probably want to keep your boat out of the water or keep it docked. Or off the beach, stay off the beach. If you choose to go out, have a plan. What if something happens when you're out there? What are you going to do? Do you know what you're going to do? Do you know where to go? Those are important things, and you want to practice that. You want to know, okay, I'm going to do this, and this is how I'm going to do it. And the reason why you practice is because in those significant events, it can be scary, and we want our muscle memory to take over. So have a plan, know your plan, practice your plan. So that's pretty much the end of the talk here. In order to get your SKYWARN certificate, you're just going to head to weather.gov/CRP/SKYWARN, enter your first and last name, enter SKYWARN 2021, and then create your certificate. And that's just kind of what it's going to look like for you. You should be able to get a printed certificate, and that would have your name and your date of your training. If you call us and give us a report, you can let us know that you were a SKYWARN attendee. It really does help us to know that we're reaching good people. We're doing a good job and making sure that you guys are okay. And we also want to make sure that you're safe. So just stay safe if you're doing any spotting, and be very cautious and careful. Thank you very much for attending today. Again, if you have any questions, any comments, anything like that, please email me. It's liz.somerville@noaa.gov. You can call our office, 361-289-0959, or you can hit us up on Twitter and Facebook at NWS Corpus. We'll answer any questions that we can, and if we don't know the question's answer, we will find it for you. But just let us know if there's anything that we can improve on, if there's any questions that you might have, or if there's anything that you would suggest for next time. I sure appreciate you, and I hope you guys have a great and safe day.